Today we're going to talk about the rational root test. So let's talk about the steps first. First, you want to make sure that your polynomial is in standard form. That means the exponents are in decreasing order, largest to smallest. Then once you have it in standard form, you're going to take the constant term and you're going to find all the factors of that constant term. We're going to call that P. And we're going to list all the factors of the leading coefficient. We will call that Q. After that, you'll list all the positive and negative values of P divided by Q. So we're going to put all those P's and Q's together. And lastly, we will use synthetic division to find all the actual roots. So this will be a list of possible roots. They might be, they might not be. And then we can divide, because remember we had a lesson on division, and if the remainder is 0, then we know that it is a factor, which means it is a root. So let's look at our first example. We have 3x to the third plus 5x squared plus x minus 1. So is it in standard form? 3, 2, 1, yes, it's in standard form. So I'm going to take my constant term here, the number without an x, and I'm going to list the factors of it, which is super easy, just 1 times 1. So remember that's my p-value. And then I'm going to go to my leading coefficient, which is 3, and list those factors, which is 1 times 3. So that's going to be my q. So to list my factors of P over Q, and the point is it could be a positive value or it could be a negative value. We don't know, so we have to use both. So we're doing P over Q. So positive 1 over a Q value of 1, or we have a P value of 1 over a Q value of 3. And that's the only possibilities that we have. So if we simplify this, our possible rational roots are going to be positive or negative 1 divided by 1 is 1, or positive or negative 1 divided by 3 is 1/3. And that's all we can do with that. Okay? So let's take a look at another example. We have x to the third minus 4x squared minus 13x plus 40. Again, we will check to make sure that it is in standard form. So 3, 2, 1, 0, it is. My values of 40, we'll have quite a few. 1 times 40, 2 times 20, 4 times 5, 4 times 10, and 5 times 8. And then my leading coefficient is 1, so my factor is just 1 there. So possible P over Q. Positive or negative 1 over 1. Positive or negative 2 over 1. Positive or negative 4 over 1, positive or negative 5 over 1. All of these are divided by 1, right? So to save space, I'm just going to simplify it, because hopefully you realize everything's divided by 1. So what's 1 divided by 1? 1. What's 2 divided by 1? 2. So we've got plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 8, plus or minus 10, plus or minus 20, and plus or minus 40. And these are all of our choices for our possible rational roots. That's a lot. Okay, let's now take a look at using these possible rational roots. So I am to state the possible rational roots, so I'm going to list my P's and Q's, and then I'm going to actually use division and find them. So for my first example, or number 3, I have x to the third plus 9x squared minus 21x plus 11 equals 0. 3, 2, 1, 0, all in standard form. So let's list our P's and Q's. P's here, just 1 and 11. Q's here, just the 1. So for my P over Q, I have positive or negative 1 divided by 1 is 1. 11 divided by 1 is 11. I have 4 choices here for my possible rational roots. So I'm going to divide to see if I can find a root. And, you know, 1's a super easy number to work with. So let's use positive 1. And it's already solved, so I can put that in my little box. And I'm going to use synthetic division. So 1, 9, negative 21, 11. 1, 9, negative 21, and 11 are my coefficients. Bring down the 1. 1 times 1 is 1. Add them together to get 10. 10 times the 1 is 10. Add them together to get negative 11. Multiply the negative 11 times the 1 to get negative 11. Add them together to get 0. So since I got 0, that tells me that this is a factor, or this is one of my roots. That's what that tells me. Well, okay, this did work. All right, so I know 1 is one of my roots, which means it's an x-intercept. That graph crosses the x-axis at 1. Now if I look at what I have left here, remember from our division practice, I go 1 degree less than 3, and I can now write that depressed polynomial. This is what I have left over. Okay, so if you can factor, you could factor and see if we can find the rest of our zeros. Remember from solving our polynomials, it's the same thing. So remembering to factor, I'm going to take a times c, and I get negative 11. Factors of 11 are 1 and 11. Negative 1 plus 11 will give me a positive 10. So I'm going to come over here. I have x squared in the front. I have negative 11 in the back. And then I plug in my 2 factors. Then I will use my grouping. So there's an x in common. That leaves me with x minus 1. Here, these two have an 11 in common. That leaves me with x minus 1 also. I will factor out that x minus 1 there. And that leaves me with x plus 11. So again, to finish solving, I have to take each factor and set it equal to 0 and solve. So add the 1 to get x equals 1. Subtract the 11 to get x equals negative 11. And please don't forget, I already had this one that I found at the very beginning when I was dividing. So if you take a look, I have a degree of 3. So I expected to see 3 zeros, and I do have 3 zeros. Now the fact that these are the same, that means there is a multiplicity of 2 here. Okay? And if you remember what that looks like on the graph, that is a bounce. So we could actually sketch a graph of this function just by knowing what we know. This is the third degree, So it's an odd number, which means they go in opposite directions, and it's a positive. So I'm going to start at the bottom and go up. I have an x-intercept at 1, and I have an x-intercept at negative 11. The multiplicity at negative 11 is 1, so I'm just going to pass right through. The multiplicity at 1 is a bounce, or a 2, so I'm going to bounce back up. So I could sketch a graph. We get lots of information. But this part is actually the answer to our question. Another example. So we have x to the third plus 15x squared plus 27x plus 13. It is already in standard form, and I'm ready to list my factors. So 1 and 13 is my p, only 1 for my leading coefficient. So my p over q is going to be plus or minus 1 divided by 1 and plus or minus 13 divided by 1. Again, I like the easy way, so I'm going to divide by 1 to see if it works. List my coefficients of 1, 15, 27, and 13. 1, 15, 27, and 13. Bring down the 1 times 1 is 1. That gives me 16 times 1 is 16. Add to get 43. Times 1 is 43. Add to get 56. So, did I get a remainder of 0? No. That means 1 is not one of my zeros. It does not work. I have to try another one. So, let's go to the next best thing. Let's go to negative 1. Again, I'm using 1, 15, 27, 13. Bring down the 1 times negative 1 is negative 1. Add to get 14 times negative 1 is negative 14. Add to get 13. Negative 1 times 13 is negative 13. Add those and I get 0. So this one did work. Now, for my depressed polynomial, I have 1x squared plus positive 14x positive 13. So can I factor that one? And I'm pretty sure my answer is yes. So a times c is 13. Factors are just 1 and 13, which do add to give me 14. So let's go with that. So I have x squared and 13. And then I'll use these factors, so 1x and 13x. Then we will group. These two have an x in common. These two have a 13 in common. So I have x plus 1, and I have x plus 13. Set each one equal to 0 and solve. And please don't forget this 0 that we had already found. Do not forget that we have that one. So again, we have x equals negative 1 2 times, so that's a multiplicity of 2, and x equals negative 13. Alright, I have one more example, and then we'll be done with this lesson. So number 5 is x to the third minus 7x squared plus 16x minus 10. Alright, 3, 2, 1. Factors of 10, 1 and 10, 2 and 5. Factors of 1 are just 1. So for my p over q, I have plus or minus 1 divided by 1 is 1, 2 divided by 1 is 2. Plus or minus 5 divided by 1 is 5. And plus or minus 10 divided by 1 is 10. Let's try 1. And my coefficients are 1, -7, 16, and -10. So 1, -7, 16, -10. 1 times 1 is 1. That would give me a -6. 1 times -6 is -6. Add to get 10. 1 times 10 is 10. Add to get 0. So this one works. Yippee. I will write my depressed polynomial. So I have 1x squared minus 6x plus 10. And try to factor. 1 times 10 is 10. Factors of 10 are 1 and 10, 2 and 5. I'm looking for a -6. So am I going to get a -6? No. What that means is I'm going to have to remember my quadratic formula. All right. Let's go. We have A, B, and C here. So x equals -b is -6. Ooh, I don't know what that was. Plus or minus the square root of b squared. So again, -6 squared minus 4 times a is 1 times c is 10. All over 2 times a. So a -6 turns to a +6. Plus or minus 36 minus 40 is a -4. Use your calculator if you want. And that's all divided by 2. So let's take a look at how we can simplify this radical right here. I have to remember this is the same as -1 times 4, and the special thing about the square root of -1 is we represent it with the letter I. And then the square root of 4, hopefully you remember, is 2. So let's go ahead and put that in our formula. So we have 6 plus or minus a 2i now. That is all still divided by 2, but if you pay attention, we can reduce. 2 divides into 6 3 times, and 2 divides into 2 1 time. So, for my answers, I have my first one that I found, x equals 1. I have this 3 plus I here, which is 2 solutions, 3 plus I and 3 minus I. This are my answers.